Hello students, today we are going to start another topic of our chapter gravitation. The objective of today's topic is to study about concept of weight and variation of g with altitude. Altitude means height, and under which we are going to discuss about concept of weight, relation between capital G and small g, and variation of g with altitude. So first of all, we'll see what is weight. The force with which a body is attracted towards the center of earth is called the weight of the body. As we know that F is equal to m into A, where F is the force, m is equal to mass, and A is acceleration. So the weight of an object is equal to mass of an object multiplied by acceleration, but here in this case it is acceleration due to gravity, or you can say that weight is another word for the force of gravity. So we can write F is equal to mg in place of ma is equal to weight. So we have a formula for weight. Weight is equal to m into g, or mg. Now let's see example by which we can be more clear about weight. Calculate the weight of a body of mass 10 kg. Take g is equal to 9.8 meter per second square. As we know, w is equal to m into g. Here m is equal to 10 kg and g is equal to 9.8 meter per second square. Therefore, w is equal to 10 into 9.8, which is equal to 98 Newton. As weight is also a force, therefore SI unit of weight is also Newton. So weight of this object is 98 Newton. Next is relation between capital G and small g. As we have already discussed in our last topic that capital G is universal gravitational constant and small g is acceleration due to gravity. Let's see how they are related. The gravitational force of attraction between a body of mass m and the earth of mass capital M is F is equal to g m into m upon r square, which is Newton's law of gravitation, where capital R is the radius of the earth. But this force is equal to the weight of the body. Therefore, W is equal to F is equal to mg. Weight of the object is gravitational force acting on it. Therefore, we are equating weight with gravitational force. When we are going to equate it, weight of the object is equal to gravitational force, we can equate these two formula. W is equal to mg equivalent to F is equal to g m into m upon r square. By equating that, we can get m and m get cancelled and small g is equal to g m upon r square, where g is the gravitational constant, capital M is the mass of the earth, and r is radius of earth, and it is one of the important equation of gravitation. You have to learn this and you should know how it get derived. Next is variation of g with altitude, means how acceleration due to gravity changes with change in height. Students, let body be at height h above the surface of earth as shown in figure. You can see here also, suppose a person is at certain height h from the surface of earth. The distance of the body from the center of earth is r plus h. As we have already discussed that capital R is the radius of earth. Therefore, from center to the position of this point P, total height will be h plus r or r plus h. Therefore, acceleration due to gravity is equal to gm upon, in place of r square we can write r plus h whole square. So, acceleration due to gravity decreases with the height from the surface of earth. We'll see detail how it comes. We have studied that g is equal to gm upon r square, where g is the gravitational constant, capital M is the mass of the earth, and r is radius of the earth. When object is on the surface of earth at this point, at that moment, acceleration due to gravity is given by this equation, right? When the body is at height h, then g dash is given by, means or value of acceleration due to gravity is going to be changed when an object is at height h. So we can write this equation as g dash is equal to gm upon, now total distance will be r plus this height, which comes out to be r plus h whole square. Now by dividing equation 2 by equation 1, we are going to get r square upon r plus h whole square. Taking r square common from the denominator, we are going to get 1 plus h upon r whole square, which is equivalent to this r, and this r is going to be cancelled, and we are left with 1 upon 1 plus h upon r whole square. And by taking its reciprocal, we'll get that g dash is equal to g 1 plus h upon r whole raised to power minus 2. Now by applying binomial expression for 1 plus h upon r square, you are going to study in detail about binomial expression in your mathematics. For now, just keep this thing in mind that while applying binomial expression here, what you have to do, you have to take this power in front of this h. This is a rule of binomial expression or binomial expansion. There are further more powers after this, but we are going to neglect the higher powers. So ultimately we are going to get g dash is equal to g 1 minus 2h upon r, which is the result of our derivation, that acceleration due to gravity changes with height with the relation g dash is equal to g 1 minus 2h upon r, right? Now what we are going to conclude after this discussion, first, g decreases with increase in the value of height. As we are going to increase the height, value of acceleration due to gravity decreases. Secondly, if h is very large, you have to take the relation g dash is equal to g r square upon r plus h whole square. From where we get this equation? Let's see. See students, on the surface of earth, g is equal to gm upon r square. At a height above the surface of earth, g dash will become gm upon r plus h whole square. Now from 1, gm is equal to r square into g, which is equivalent to g dash r plus h whole square, or you can say that g dash is equal to g r square upon r plus h whole square. So there are two relations. First relation is g dash is equal to g 1 minus 2h upon r. We will take that relation when height is small, but if h or height is very large, you have to take this relation. So here is a graph which is one of the important graph in gravitation. How g varies with altitude. See, on the surface, this is earth and this is the surface of earth. On the surface of earth, acceleration due to gravity is 9.8 meter per second square, which is approximately equal to 10. As you are going at a height, as the distance from the surface increases, acceleration due to gravity goes on decreasing. Alright, this is from surface to certain height, acceleration due to gravity decreases from 10 meter per second square to approximately equal to 0, but it is not equivalent to 0. And we'll study in the next topic that when we goes deep inside the earth, how acceleration due to gravity varies. But for the now, we'll see only as we increases the height, acceleration due to gravity decreases. And you have to learn that two relations. Now we'll take an example so that we will be more clear about the concept of variation of g with altitude. What is the value of g at a height 8,848 meter above sea level? Given g on the surface of the earth is 9.8 meter per second square, mean radius of the earth is equal to 6.37 into 10 raised to power 6 meter. So let's see what is given. We are given with h is equal to 8,848 meter, g is equal to 9.8 meter per second square, and r is equal to 6.37 into 10 raised to power 6 meter. And what we have to find? We have to find new value of g, right? Means g dash. Now let's see the solution. As we know that g dash is equal to g 1 minus 2h upon r. G value is 9.8. 1 minus 2 into h value is 8,848 meter divided by value of r is 6.37 into 10 raised to power 6. After solving this, we are going to get g dash is equal to 9.77, or we can say that g dash is equal to 9.77 meter per second square. Alright, it means value of g changes when we increases the height. Initially it was 9.8 meter per second square on earth. Now it becomes 9.77 meter per second square when the body is at height of 8,848 meter. Okay, now you are able to answer all these questions. Question number 1, define weight. Calculate the value weight of a body whose mass is 5 kg. Number 2, write down the relation between the universal gravitational constant capital G and the acceleration due to gravity G at the Earth's surface. Next question is, discuss the variation of G with altitude. You have to derive the relation. Next one is, when a pendulum clock is taken to a mountain, it becomes slow. Why? Here I am going to give you a hint that you have to use the relation time period of a simple pendulum, that t is equal to 2 pi under root L upon G. After taking that relation, you are able to answer this question also. Okay, and the last one is the numerical. On the surface of Earth, a body weighs 99 Newton. What is the gravitational force on it at a height equal to half the radius of the Earth? That's the end of the topic. Thank you.